Hello, boys and girls. Welcome back to another edition of Think Different Television. All right, so we are classifying triangles not by angles this time, but by the sides. Oh my goodness. So here are the three different ways you can classify a triangle by its sides. If all three sides of a triangle are congruent, then the triangle is an equilateral triangle. So equiangular if all the angles are congruent, but equilateral if all the sides are congruent. So it's going to be the same picture regardless. So if at least two sides of a triangle are congruent, then the triangle is an isosceles triangle. If no two sides of a triangle are congruent, then the triangle is a scalene triangle. Okay, so take a second and copy that down into your notes. Geometry is all about vocab. Here is mine right here. So it should look like something like this. Yeah, like this. Pause the video if you need. So let's take a look. So here's A, B, and C. Ejemplos, examples, right here. So A, B, and C. Draw those in your notes when you're ready. And we're going to classify them, okay? So A, what is this? Well, I see two sides are congruent. And so therefore, this is at least two sides are congruent. So this is an isosceles triangle. And also with the isosceles triangle, sometimes it's going to label certain angles of it. So this angle is called the vertex angle. Write that down. And these angles at the bottom of the congruent sides are called the base angles. Like that. So these are the base angles. That's the vertex angle, which is at the top of the two congruent sides. Okay? So that's an isosceles triangle. B, what is this? Oh, two marks, all the same mark on every side. So this is an equilateral triangle. Now here's something weird. They're going to try to get you on the EOC. Look at this definition. At least two sides. So if you must be like at least 2 feet tall to ride the ride, that means you can be 2 feet tall and everything above it, right? So this is at least two. That means everything above 2 and above. So that's three sides also. So equilateral triangle is also an isosceles triangle. Weird. Primarily, it's going to be called this, but it's also going to be classified as this because the definition says at least two sides of a triangle. And at least means two or more. All right, let's try C. What's this? Ooh, I have 23, 12, and 15. I look at the length of every side, and they're all different. So no two sides are congruent. So this is called a scalene triangle. That. Scalene triangle. All right. So now there are 6 examples right beneath on your worksheet right here. 1, 2, 3, 4, 5, 6 right here. I want you to copy those down, and I want you to classify them as equilateral, isosceles, and scalene. Okay? 1 through 6, copy down, and then classify. Ready, set, go. All right, see what we got. So 1, 2, and radical 3, those are all different values. And so number 1 is a scalene because no two sides are congruent. Okay, let's see this. 18, 18, 18. All the sides are congruent, so this is a equilateral triangle. But we also learned before in their example, at least two sides are congruent, so we also call this an isosceles triangle. Primarily, it's equilateral triangle, though. You gotta have both. 3, 12, 17, 19. All of these are different measures, so this is a scalene triangle. If you didn't get this right, you're fixing it on your paper. Ooh, 4. What do we call this? Ooh, two sides congruent. This is just an isosceles triangle. Here's the vertex angle, and here are the base angles. Vertex angle is angle S. You're going to need this coming up in one of our problems we're about to do. Ooh, what's this? This side and this side are congruent. Even though it has X, you can plug in anything for X, and you're going to get the same value. If you plug in 1, you're going to get 32 and 32. If you plug in 2 for X, you're going to get 64 and 64. So it doesn't matter what you plug in for X, you're going to get the same value for these two sides. So this is an isosceles triangle. Because the third side's a different value than the other two, so you have at least two sides congruent. What's 6? X, X, X. So that's going to be the same value. What? 2, 2, 2, 3, 3, 3, a half, 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 1.7, 1.7, 1.7, whatever it is. So this is going to be an equilateral and an isosceles triangle. Cool. That's how we classify. Now, let's get a little more complicated. That's too easy, right? So, let's look at these problems right here. Number 7 and number 8. So what happens if we don't have a picture? What happens if we have some algebra in it? Okay, no problem. So look at number 7. Find the measure of each side of equilateral triangle RST with RS equal 2x plus 2, ST equal 3x, and TR equal 5x minus 4. So EOC loves to do this. They like to put these problems in without a picture, and so that's why you have to draw one. So I'm going to write all the important information in my notes like this. Pay attention to this and make sure you have it because you're going to have to do one on your own after I do these first two, okay? One equilateral, one isosceles. So equilateral triangle, RST. So I'm just going to RST. So it doesn't matter what order. RST or RST, doesn't matter. I just start on the bottom left, usually. RST, like that. As long as they're in a row, you're good. I could have done RST. You get the same thing. Now I label. So, first is equilateral, so that means that all sides are congruent. Make the marks like that. So RS, this side, is 2x plus 2. Got to have a picture. ST is 3x. I copied this down from the problem. And then TR is 5x minus 4. Okay, so I need to find the length of all the sides. So if they're congruent, that means I can set the equation. So that means this side equals this side, right? What about this? Is this side equal this side? Yeah, I could do that, or this side equal this side. So it doesn't matter what two I pick. I should get the same answer. Let's just check. Let's pick these two and put them equal to each other. Make sure it is legit. There we go. Okay, so if I'm solving this, subtract 2x on both sides. 2 equals 1x, so x equals 2. Would I get x equals 2 on this? Because I picked those. Doesn't matter which ones I choose because they're all congruent. Let's see. Subtract 2x here. 2 equals 3x minus 4. Add 4. 6 equals 3x. Divide by 3. 6 divided by 3 is 2. Yeah. So no matter what I chose, I got 2. So if I chose this equals this, I would get 2 also. So we're not done yet because it asks us what the measure of each side is. So I'm going to plug in 2 into any one of these. I'm going to plug in 2 right here, right? 3 times 2 is 6. Do I have to plug in here? No, because I know they're all congruent, and so this is 6, this is 6. If I plugged in 2 here, I would also get 6. 2 times 2, because x is 2, is 4, plus 2 is 6. So all sides are 6 right there. That's the answer. Got it. Okay, now number 8. Before you do it, I'm going to do one more. Here you go. Number 8. Find the measure of each side of an isosceles triangle, ABC, with AB equals CD. Okay, so that means two sides are congruent. AB equals 4y, BC equals 3y plus 2, and AC equals 3y. Okay, copy the important information down in your notes. Let's check it out. Doot. Here's my important information. Copy that down if you don't have it. Okay, so here's my triangle. This, gotta have a picture. So ABC, so A, B, C. I always start on the bottom left. Doesn't matter how you start it. You could put A here, then B, then C if you want. You're cool. So now I need AB equals BC. So AB is here, equals BC. I don't put a congruent mark here because it's an isosceles triangle and only two sides are congruent in this case. So now I'm going to label with this. So 4y equals this. BC equals that side, and then AC is 3y. Okay, so now I have to figure out the length of all the sides. So we have 4y, and so this and this have to equal each other. Those don't equal each other because it's not an equilateral triangle. So the only option right here is to set these two sides equal to each other. Like that. Now solve. What do you get? That's 1y equals 2, and so y equals 2. 1 times anything is itself, so y equals 2. So now I got to find all the sides. So 4 times 2 is 8, If this side is 8, this side is also 8. But this side's not 8. This is 3 times 2 because x is 2. 3 times 2 is 6. So AC is 6. AB is 8. And BC is 8. So something like that would be a good final answer to write. All right. Now your turn. Yay. Here you go. 11 and 12. Remember vertex angle? Look at your notes if you need. Ready, set, go. Do 11 and 12. All right, let me do it. Here you go. Number 11 and 12. Okay. ABC is equilateral. I'm going to go faster on this. So ABC. AB is 3x minus 2. BC is 2x plus 4. All sides are congruent. X plus 10. So I'm going to choose two sides. It doesn't matter. Let's choose these two. 3x minus 2 equals 2x plus 4. Subtract 2x. X minus 2 equals 4 plus 2 plus 2. X equals 6. Cool. So x 6 plus 10 is 16. Is that true for all of them? 3 times 6 is 18 minus 2 is 16. Yeah, they're all 16. So AB, BC, and AC all equal 16 in this case. Yeah. Next one. DEF is isosceles. So what does it say? It says D is the vertex angle. So that is this angle on the top. Because these are the vertex angles. Remember that? So this means that this could be E, this could be F. Doesn't matter. So if this is the vertex angle, these are the base angles. Remember from your notes when we started. You always got to look back at your notes. That's why we have it. That was our hint. So DE is x plus 7. Write this down if you didn't get it. And DF is 3x minus 1. And then EF is 2x plus 5. So I need to set these two equal to each other because I have the congruent marks, which means these two are equal measures. So x plus 7 equals 3x minus 1. Subtract x on both sides. 2x minus 1. Add 1. 8 equals 2x. 2 times what is 8? That would be 4. Plug it back in. Plug it back in. 4 plus 7 is 11. So this side's also 11. 2 times 4 is 8. 8 plus 5 is 13. Yeah. So EF is 13. DE and DF are both 11. Nice job. If you were confused with this one or the other ones, look back on it and redo them. Good work, everybody.